a weekly look at what's happening at AWS and how it may change how you do business. My name is Michael Krause. I am your host today. I am the Chief Technology Officer at Charter Solutions, where we help organizations change and innovate quickly by accelerating their acquisition and use of data.
And I'm your co-host, John Athelter. I'm a lead technical architect on the AWS specialist team at Salesforce, where we work with potential customers, helping them envision the possibilities that AWS and Salesforce enables.
Excellent. Well, welcome back for another show, John.
Welcome back, Michael. Show 20.
Yep, and starting our countdown to reInvent. We were just talking about reInvent a little bit before we started here, and I think it's going to be fun. With COVID, it's been a while since I've actually been there in person.
Yeah, this will be my first reInvent, so I'm pretty excited for it.
Well, in today's episode, we're going to take a little bit of a deeper dive into AWS Glue and see what kind of capabilities it brings to the table and what it has to offer.
All right. Well, Michael, I always like to start off with a nice, easy question of, I guess AWS Glue has a lot of different things that kind of connect to it. But overall, what is AWS Glue?
So AWS Glue is a suite of services. And this is the moniker is a little deceiving because people talk about Glue, but it's used in a variety of different ways and has a variety of different capabilities. So Glue is used for a number of things, including discovering and organizing data in your data lake, transforming, preparing, and cleaning your data for analysis, building and monitoring data pipelines. It's got a lot of different features around those different things.
Yeah. So, I guess what are the different elements of Glue, and maybe how might they be used differently by different types of users?
Okay. Well, let's talk about a few different things. So when we think about data lakes and managing data in data lakes, you need some way of letting people know what's there and what's available. So this is cataloging and metadata management and things like that. Starts to roll into a little bit of governance and data lineage. But Glue has this thing called Glue Catalog is one of its features. And the Glue Catalog capability is really around organizing and managing the data lake data and capturing metadata around it. And there's two key features that are kind of organizational concepts that they use. One is databases and one is tables. So it kind of relates to people who might be used to the typical data warehouse, data mart, or relational database world. But these aren't relational databases. They aren't actual relational tables. They're really more conceptual organization of the data.
Okay, and what is Glue? I guess if people aren't familiar with Glue, what are some of the things that are running under the hood of Glue that people might be familiar with from other types of environments?
Sure. So on the catalog, let's stick to the catalog for a second. But if you think about the catalog is really a Hadoop Hive catalog underneath. So it can be used if you're actually running Amazon EMR, Elastic MapReduce, their Hadoop implementation. You can use Glue as your data catalog as opposed to running a separate catalog as well.
Yeah, and the catalog, it definitely, I would say that's probably the biggest piece of AWS Glue that is the glue, in my opinion. What are some examples of where you'd utilize the catalog, when you're working across a lot of other types of services with AWS, and how Glue, I guess, got its name, for lack of a better term.
Yeah. Glue is really good at gluing things together. And as we talk about other capabilities of Glue, you'll start seeing more of that. So the catalog is really interesting in my mind because we talk about data lakes, and a data lake on AWS is typically stored in S3. It could be JSON, could be CSV, could be Parquet, Apache Iceberg, different file formats. But the catalog allows you to take that data in those files and organize it so that you can have database that represents groupings of things. So think maybe a data mart or a data domain. And then within that, you can have tables that represent specific subsets of that data, right? I might have users, I might have purchases, I might have invoices,
Mhm.
all those types of things. And the nice thing about Glue is it doesn't necessarily limit itself to just data lake data in S3. You can, and we'll talk about this a little bit later, you can actually connect up databases to Glue. You can connect up Redshift, you can connect up um, Aurora, Amazon RDS, various, basically anything where you've got a network path and a JDBC connection capability. All of those things you can connect up to your Glue catalog.
And I guess how do you get all that data in there? How do you feed that, and how do you continually make sure that it's updated with the right amount of data and the right
Yes.
and the right type of data?
Yeah. So there's a few different things that we look at. There is the data actually bringing the data in and processing the data, but there's also the once your data is there, how do you make sure that the catalog is updated? Let's start with that second one. So Amazon Glue has this concept called Glue crawlers. They're part of the whole kind of data catalog capability. What Glue crawlers do in the data lake world is they go in and they will take a look at the files and they will attempt to determine what the schema of that data is by analyzing the files themselves, right? So if you think about a CSV file, I drop a terabyte of CSV files into S3. I want to make them available in the Glue catalog. I can go and create a crawler pointed at that terabyte of files and have it go through that. And what the crawler will do is it will look at all the columns in the CSVs. If we've got headers in there, it'll pull those names off the headers to say, here are my fields. Then it will actually look at the data within that and make a determination of what type of data is this, right? If they're all integers, it'll say, this looks like an integer column and it'll mark it as integers. If it's a mix of numbers and letters and all that stuff, it'll make it a string. If it identifies a date column, it'll mark it as a date column, right? And you can always go in and manually override it and change it. But the crawlers allow you to very quickly take data from an external source or from S3 and make it available in the catalog. And the importance of that is as soon as it's in the catalog, now you can query that data with any tool that allows you to query against data managed in the data lake via Glue. So Amazon Athena, Redshift Spectrum, all kinds of different things like that.
What are some of the places, or what are some situations where you might have to lean on doing some manual changing of the data types, or maybe kind of go outside of the regular automated kind of drop click or point and click capabilities?
Yeah, absolutely. So um, let's stick on the topic of Glue crawlers again, and then let's swing back to this a little bit later when we talk about data processing and ETL jobs with Glue. But we talked about crawlers and their ability to read different files. AWS Glue out of the box comes with the ability to look at Apache Avro, Apache Orc, Parquet, JSON, XML, CSV, binary JSON. These files it can handle out of the box. If you've got other files that you need to be able to process, you've got a couple of options. One is you could run through an ETL process and convert them to one of these and
Mm-hmm.
then crawl it with the crawler. Or you can build what's called a custom classifier. So the classifiers are basically the tools within the Glue crawler that looks at the file and says, oh, this is what it is. And this is what the schema structure looks like, right? So say you have a pipe delimited file or an EPSIDIC or a fixed column file, right? You could go through and actually create a custom classifier for that and then have that custom classifier go through. So when would you create a custom classifier versus not, right? If you have a one-off situation where you've got that file format coming in, it probably makes more sense to write a Glue ETL script that'll just convert that file format to CSV or JSON or something that can be classified automatically. On the other hand, if you're pulling in files from, your mainframe, and every file is a fixed column with file, and you've got tons of different data sets coming in, you're probably better off creating a custom classifier so you can always classify them even when you've got new files that come in.
Yeah, no, absolutely. And I think, not to get off subject, but I think there'd be interesting situations where you might utilize some of the custom classifiers versus maybe utilizing some things in the new Lambda object update,
Yep.
and how you might, yeah. So I think, you also said stuff about, you can get in there and look at schemas. So,
Right.
talk a little bit about that.
Right. So, going back to the database and tables piece, when you go into the Glue console and go to the databases section of it, you can take a look at all the tables you've defined in there. Now, remember, one of the tenets of a data lake is schema on top of data, not data inside schema, right? So we have our data, and we create a schema that describes the data in the format that it's stored. So if I have a CSV file, it's not like a relational database where I create my schema and my table structures, and then I have to massage my data into them. I take a look at this um, CSV file, and my schema is really just telling, Athena and those tools, here's how you have to interpret this file when you query
Mm-hmm.
it. So you can go in and say, oh, the crawler said this was a string. It just missed out. It's really a number. It's an integer. I can make those changes inside that. It can crawl and recognize nested structures. So, for example, JSON. You can have a nested JSON. It'll recognize that, and it'll keep the top level ones.
Mm-hmm.
We'll talk about the concept of flattening that when we talk a little later about ETL. Um, but you can also start capturing metadata. So you can tag your schemas and capture a lot of information about it. You can profile them, capture some basic information around the profile of the data. You can maintain history. You can capture um, lineage information. Where did this data come from, right?
Mm-hmm. Mm-hmm.
So there's a lot of information available that you can make available in the catalog. Now that said, um, I personally think the Glue catalog is a great tool for the data geeks, for the people who are, very conversant with the technical side, with the concepts of schemas and stuff like that. It's not really what I would call an end user catalog.
Okay.
So we've got an analytics end user. This is not a catalog that typically they would use without a lot of education and
Mm-hmm.
understanding about that. But in another session, when we talk about QuickSight and the QuickSight data sources and stuff like that, we can talk little bit about how you can leverage QuickSight to make that a little more usable, that information more usable for those end users.
What are some other sources, and what are some other ways and connections that you can get into Glue?
Getting into Glue, so um, if you think about the data that can be crawled and where you can go with that, you've got native stuff like Amazon S3, which we've talked about a lot. You can also crawl DynamoDB tables and bring that stuff into Glue. I mentioned JDBC sources, so that could be Redshift, it could be Amazon RDS, any RDS database that supports a JDBC connector, Amazon Aurora, but also it doesn't have to be running inside Amazon. It could be an on-premise database through either Amazon Direct Connect or via a VPN connection. So think MariaDB, SQL Server, MySQL, Postgres, Oracle running on premise. We can connect up to those with Glue as well and catalog them. And then MongoDB. So if you're running MongoDB or even Amazon Document DB, you can connect up to those. So it's not just files on S3 that you can catalog in Glue,
Yeah.
but it is all kinds of different data sources, and this becomes very important. When we start talking about data pipeline processing,
Yeah.
ETL transformation, because now you have the ability to bring data from many different sources together in a single Glue job.
Yeah, and that's one that I think about quite a bit too. Is just if you're really utilizing AWS as your backbone and essentially Glue Catalog as your metadata layer, um, you know, you kind of want to be able to be able to hook up to all these different sources. And I guess I wanted to ask you of just your own personal experience. Do you have any any good stories or maybe nightmares of connecting up to sources outside of AWS that you can share at all?
You know, the big thing that we run into is, well, I could share a couple of little nightmare scenarios that we had run into that I think are now fixed. I remember we had one uh, we were creating glue jobs that processed a lot of incoming data, and uh, as part of that, had to merge it with data from Snowflake,
Mhm.
and then it had to write the results back out to Snowflake.
Yes.
And the problem we were running into was getting all of the libraries required to make that happen in a size and structure so that it didn't exceed the glue's limits for library stuff.
Yeah, that's there's
And,
probably a lot of depending on that the data that's doing that. There's probably a lot that could be going over in that one workload. So
well, what's interesting is we found, and I'm hoping that Snowflake has trimmed this and shifted, but I think AWS has actually increased the limit as well.
mhm.
But the transitive relationships, the transitive dependencies of the Snowflake libraries had a large of big thing, a lot of large things.
Yeah,
So it had the entire pandas library, all of the transitive dependencies of pandas, all this stuff in there, and it made for a very large source. And we actually ended up going in because a number of those libraries are actually available natively to the Glue jobs already by AWS. So we had to go in and do exclusions and stuff like that
yeah, yeah, yeah.
to get the whole thing down, because now we've got a secondary libraries, a set of libraries that we're trying to bring in, and there's a limit on how big that could be.
Yeah, the curse of dimensionality of features.
Yep, absolutely. But yeah,
So
but overall, in the end, it never became a data problem because Glue, and we're starting to kind of shift into the transform and prep.
yeah, yep,
Glue is really built for very, very large data sets.
yeah.
It works really well with small data sets as well, but it's built to efficiently handle very large data sets.
I and obviously Glue, the processing part of it, it's Spark under the hood.
Yep.
I've always, as soon as I heard about Spark, many years ago now, I was like, there's always technologies that get absurded, and I was like, this is like the one ring to rule them all sort of type of deal. So it's definitely an amazing technology, and you had stated a little bit about being able to transform and prepare and clean large amounts of data. What does that look like in a Glue experience, and what are
Right.
some of the different experiences you might have, maybe based on position that you're in?
Okay. So, let's talk about early pipeline. So Glue has these ETL capabilities, typically referred to as Glue jobs.
Hmm.
And there's a number of different ways you can create Glue jobs, but in general, Glue jobs run on Spark. So you can write them in PySpark. You can actually write them in Scala if you want to. Um, but I say that in general because
Yeah.
Spark is it consumes a lot of resources to run.
Hmm.
It's a great tool, but if all you need to do is take a 1 meg file and convert it from JSON to CSV or Parquet, it's kind of overkill,
Yeah.
right? So Glue also provides kind of basic console Python as well.
Hmm.
So you can just write a simple Python script that will open the data, do whatever you want to do in Python, and write the results back out. And it's going to be single threaded for the most part, but that's fine if all you have is a little thing. I have a file that comes in once a night. It's got 20,000 entries in it, and I need to convert it from CSV to Parquet.
Yep. Boom.
Doesn't make financial sense or time-wise sense to run that on a Spark cluster. It's better to just do that in Python. On the other hand, I get a terabyte of new log files in a day from Datadog.
Mm-hmm.
Okay, well, okay, that may make more sense to run on a Spark cluster, right?
Yeah. Well, how about leveraging compute? Or are you able to leverage compute on EMR at all?
So
Or
you can definitely leverage compute on EMR. So let's talk about the difference between EMR and Glue.
Yep,
Well, you've mentioned already that Glue jobs are running for the most part Spark under the hood,
yep. For
right?
the most part, yep.
So can I run Spark jobs on EMR? Absolutely, I can.
Mm-hmm.
The difference being is that Glue is serverless, right? With Glue, I define my job, I write my PySpark code, um, and then I say, hey, I want to apply this many resources to it, right? And Glue has their own kind of generic resource sizing kind of thing. I think they call them data processing units, DPUs.
Yep,
You can
yep,
say, hey, to run this job, I want 2 DPUs, or I want 10 or 20 or 30 DPUs, right? If I'm processing 5 terabytes of data that are dropping in on a daily basis, I might go 10, 20, 30 DPUs so I can get it done faster rather than say, hey, let's do two. um, with EMR, you have a cluster you need to spin up that you then need to manage, right? Pretty easy to spin up a Spark cluster on EMR, but then you need to inject tasks into it and
mm-hmm.
run those tasks on EMR. So there's a little more overhead, a little more maintenance. You can spin them up on demand, or you can have them running. And a number of years ago, I did some data lake work with a AWS customer, and at that time, they had so much data coming in so frequently that it made sense for them to manage an EMR Spark cluster and
Yeah.
inject tasks as the data came in. Okay.
I was hoping you were going to get to this example. I love hearing about this.
And at that time, that was actually the right answer because the Spark jobs for wouldn't have been the best for them for a couple of reasons. One is um, time, because there is a warm up time with each Spark job.
Yeah.
I want 10 DPUs. It has to allocate those 10 DPUs. And if it doesn't have any hot or warm ones, it has to spin them up from cold. So there's
Uh,
a startup time that exists. Then there's the actual runtime that happens, right? So you eat a little bit of extra latency and time in that process. Whereas if you've got a constantly running Spark cluster that you're injecting tasks into, it's really just, do you have enough capacity on that cluster to process all those tasks or not? And you might need to scale it up or down or just let some tasks wait. But you've got finer grained control on that.
yep.
The other aspect is cost, right? So with serverless, you're paying a fixed cost for a period of time. And it used to be, and Spark is not cheap. I won't, don't quote me on this one, but I want to say it's like 44 cents an hour per DPU.
Yeah.
Right. So if you have a job that takes an hour and takes 10 DPUs, it's $4.40 to
You,
execute that job.
you pay for that managed service. And
Yep.
I recently saw a post where, somebody, they have a pretty mature application that it hasn't changed much over 10 years, a good engineering team. And they're like, we're moving back off the cloud, going back on prem. And I kind of thought, well, maybe that, just for cost wise and stuff like that, but that might make sense for a company that has an advanced engineering team. Everyone's been doing something
Yep.
similar. you know if you're trying to provide value statements, where do you feel like that trade-off is between the ability to really get things going and get other people working on it versus maybe you have an advanced engineering team and you want to do something like that just for pure cost savings? But I'm under the impression that, hey, well, maybe things are going to change in the next year, and then you might be in a bad situation though too.
So you've got a couple of things you need to watch there. The first one is, I'm talking about a story that happened a few years ago,
Yep.
right? Well, a lot of changes have happened with new jobs, right? So one of the changes is you no longer pay by the hour. You pay by, I think it's just you pay by the minute.
Yeah.
So if a job takes 10 minutes, you pay for 10 minutes,
Hmm.
right? Um, they are faster at spinning these jobs up. You can now create chained pipelines of jobs, so you
Hmm.
can actually dive into pre-warmed resources as you move from job to job. So there's a whole bunch of efficiencies that are being added to Glue. They also now have Glue streaming, so you can actually stream data into a Spark job in Glue
Hmm.
and process that in real time. Um, so here's kind of the really coarse answer to the question, which is today, if you take a look at that, if you just do Glue jobs, all you need is somebody you need a data scientist who's familiar with pandas or PySpark, right?
Yeah.
They can do
Hmm.
data frames and they can do Python. They can pretty much write Glue jobs,
Yeah.
and without a lot of education, they can schedule them and get them running. You do the same thing on EMR. You still need that skill set, but now you need people who understand Hadoop, understand EMR, understand monitoring EMR, scaling EMR, upgrading EMR, all of those things, right?
Yep.
So let's assume, just for the sake of simple conversation, that a person with that skill set costs $100,000 a year in salary.
Oh, wouldn't that be nice?
Wouldn't that be nice? Let's say they're higher end, and with benefits and everything else, they cost you $200,000 a year.
Yeah.
So now the question is, assuming that you could actually run the EMR cluster and monitor it, maintain it with just one full-time person with that expertise, is the cost savings on using EMR Spark versus using Glue Spark $200,000 or less?
Yeah.
Right?
Exactly.
So it's an interesting thing where I can look at the dollars and say, yes, oh gee, Glue is more expensive, but the reality is when you look at total cost of ownership, you need specialized expertise to manage that EMR cluster well.
Yep.
And if you're not already invested in Hadoop as kind of a core mechanism in your corporation, that's something you have to bring in. That's something you have to pay for.
Yep. And I think it would be a really interesting value proposition. And I'm just thinking from a pure sales even standpoint of being able to really track the amount of time that it takes for specific types of tasks for different levels of engineers,
Mm-hmm.
which is that could be very sporadic based on tasks, obviously, but really taking the time that it takes to do all of these things and not just do all of them, but switch from one type of concept to the next type of concept, to the next type of concept, and really doing the total cost of ownership that way because it beyond even salary there's a lot of just unseen efficiencies that you get when you're utilizing a managed service. And I think that becomes exponential as the more tasks and more variety of tasks that you have to do. So I think it'd be interesting to be able to get some math around that. I don't know how that would be possible, but
Well, yeah, we could plan an episode like we did with Fargate and Lambda and take a look at where do the costs converge and take a TCO kind of point of view on it as well, and maybe put some numbers together to at least create conversation.
I think it'd be interesting. We'll get two equally skilled developers on here, and we'll each give them a task. And one you go on open source or the cheapest version possible that's still at equal performance. The other one do managed services, and then we'll compare. It'll be a
Yeah.
race. I think that'd be something interesting to do.
Well, the other thing that to kind of put this whole problem into terms that business people would understand is it's a build buy decision,
Yes.
right? So, I mean, take a look at most corporate business systems. I would say, in the 15 years I've been at Charter, I have only seen one company who wrote their own email system.
Huh. One
Why?
company.
I'm not going to say the name,
Yeah,
but
best practice.
yeah, but why wouldn't you do that? Or why would you do that? Right? There's Outlook, there's Gmail, there's SMTP, there's all kinds of mail systems that are very robust out there.
Yeah.
Why would you build one yourself when you could buy one. It meets all the needs, right? It's the same thing that you do with ERP systems, right? If the ERP system meets my needs, why do I need to go build my own custom one? But there
Yep.
are companies who are in niche areas, who are on the outside edges of things, where the off the shelf software will not work, or um, what they're doing is a competitive advantage and they need to have tighter IP control on it,
Yep.
right?
Absolutely.
So, in those scenarios, yes, there will be companies out there where part of their value proposition into the world is based on their ability to run a finely tuned EMR cluster.
Hmm.
But that's not the 80%,
Yeah, that's
right?
absolutely.
The 80% world is my ability to run an EMR cluster adds zero value to my
Yep.
customers, right? So, why am I investing in that skill set when I have
Yep.
something like Glue that can do it at what would end up being a lower cost and lower risk when I do a TCO analysis? And again, I'm speculating a little bit here, and
Yep.
it would be fun to do that actual numbers analysis to see where that goes.
Yeah, no, I think that'd be a good exercise. So, to bring us back a little bit more in the transform and prepare, what is the user experience like when you come into Glue, and what is what is that experience like maybe for different types of positions? So you said data scientists could
Yep.
easily utilize Glue and build their pipelines. So
So let's talk about how you build a job in Glue,
yep,
right? And there's a number of different ways. And the first one is a newer tool set called Glue Data Brew.
yep,
And I'm just going to mention it in passing because we're going to have an upcoming episode specifically on Data Brew, because Data Brew brings a lot of things that you can do in Glue, in the other Glue tools, out in a highly visual way, and includes things like data profiling and all that stuff. It's a really cool tool, and it's going to have its own episode. But moving on to the other ones, there's Glue Studio, and Glue Studio basically gives you kind of a drag and drop configure a flowchart mechanism to build a job, right? So you can say, I'm going to pull a data file out of S3, right? So let's assume that uh, we have a CSV file in S3. Better yet, let's make it a JSON file.
yeah,
We have a JSON file or a set. We've got 25,000 JSON files in S3, and I need to one get them into Apache Parquet format so that they're more efficient to query.
hmm,
Two, I have to filter out certain records that meet a certain criteria.
yep.
Three, the dates are weird and I need to convert the dates
Always the
into
case.
a proper date format that can be queried, right? So let's just start with that, right? So in Glue Studio, you drag on a data source and say it's S3 and point to where the bucket is and tell it you want it to recurse that bucket and go through all the directories and pull all the files in. Then I might say, all right, the next thing I'm going to do is I'm going to filter out the data I don't want, because
Hmm.
why change the date formats on things I'm going to delete anyway, right?
Yes.
So I might create a remove rows, delete rows. I can't remember the exact name of it. You know, uh,
Yep.
item onto it, and then tell it, give it the criteria, and say, okay, if anything that matches these criteria, remove from this data set. Pretty
Hmm.
simple. Now I want to change the date format. Drag a field format kind of thing on there. There's actually a string one where I can convert a string. So say it's in a weird string format. I can
Yep.
actually take that string, change it into a recognizable date format, and then I can apply a map step that will take that field type and change it from string to date now. Okay, and then my last one is I do a basically a data output and tell it I want to write it into this other S3 bucket and I want to do it in Parquet format.
Yep. And
Okay.
then have that. Then it can be queried by Athena, by or QuickSight, even.
Yep.
And
I can crawl that result into Glue and have that there, and it can be, queried from a whole lot of different places. But now I've taken and visually defined my job, and I can go in and schedule that job to run on demand on a daily basis, based on events that happen, all kinds of different ways I can make that job run. Now, what's happening behind the scenes there is it's actually creating PySpark code.
Mm,
So each one of those things, it's what it's done is said, here are common things people do. Think of it like functions in a programming language, right? Here are common things that people do, and here are the variables you need to define to be able to tell this common thing how to do it.
yep.
So it's like, I drag that read from S3 in, I have to tell it where the bucket is and a few other parameters to I tell it it's JSON data that I'm reading and stuff like that. So it's generating Python code, specifically PySpark code behind the scenes, and it's going to run that job on top of Spark. It'll be a Spark job that runs. But that's all it really took for me to do all that processing, define all that processing, including the conversion to Parquet. So that's pretty easy. Now, the reason I share that that's running PySpark code behind the scenes is one of the other cool things you have is you've got a special step, which is a custom code step where you can literally drop it in and create a PySpark function that gets applied to all the records at that step.
So why would you? So again, it's like, then you don't need to use then you can make that shift from Jupyter notebooks that you're
Right.
utilizing all the time.
Right. Well, and so let's talk about Jupyter notebooks.
Yeah.
All the stuff that I'm talking about is generating PySpark code, right? Well, one of the other ways you can create these things is you can use, it used to be called developer endpoints. Now it's interactive sessions. You can create an interactive job session,
Yep.
which basically fires up a Jupyter notebook. And you can go through and interactively build out your entire processing. So anything you can do on Spark with PySpark, you can do there, including all the extra stuff that AWS brings into it via their libraries. So a lot of different things you can do. If you have a very special thing you need to do, but everything else is pretty basic, you could actually start out in Glue Studio, sketch out the vast majority of it. It will produce the PySpark script. And then you could take and grab that and go into a Jupyter notebook and just add what you need to add to it.
Yeah, see, there's the way, and
Right?
usually it's the other way around where people are working in their notebook and then they go into the system and like, oh wait, I have all this other work I still have to do
Yeah.
to get it
But
going.
again, this is that 80-20 thing, right?
Yep.
There is that 20% of people who need that Jupyter notebook, who need to go in and do things. But
Yep.
there's that 80% of people that say, I need to read this file. I need to convert some dates. I need to drop some fields. I need to drop some rows. And I need to write it out as Parquet.
Yep.
I
And
don't
you
need
know
to
what
really
I'm
know
getting at is
PySpark to make that happen.
usually, or what I'm getting at is usually people start in the notebook and then they'll come back into the system. But here, if you can start and you have a good idea of what you want to do, you can get that framework done in Glue Studio, and then you can do all your customization and do it that way, and then you're just ready to go from the
Yeah.
start.
Yeah. Well, and I'll give you an example of one I've done recently is where I actually did just that.
Yeah.
I have log files that are coming in JSON, and they have nested data,
Oh,
typically nested attribute data. It's like nested name value pairs. Think about it that multiple layers
yeah,
of
that's
nested
fun to
name
query.
value pairs, right? And I need to be able to treat each one of those nested name value pairs as an individual data element.
Hmm, very fun.
So I've got all my top level JSON fields. And then inside this one structure, I've got a second level of name value pairs, of which some of them are structures with more name value pairs in them, right? So let me tell you what the end was, and I'll tell you how I got there. The end
And they're
was,
all different too. All they have different levels depending on which one
yep.
too. Oh,
But
great.
luckily, there's consistency, right? The same thing doesn't show up in different places. If it's there in a record, it's there in a record at the same level of the hierarchy.
Okay.
Okay. So what we ended up with was a flat table in the Glue catalog that had all of the top level elements in the JSON, and everything from that one structured, nested field has been flattened out to dotted notation.
Oh.
So if the field is attributes, and then underneath that it's attributes, and then there's a name with a name, it'd be attributes.name or attributes dot whatever, right?
Yep.
And if there's three levels, it's attributes dot whatever dot whatever.
Yep.
So how did we get there?
Yep.
Okay. Well, the files are coming in JSON. in the end, they needed to be in Parquet. We needed to make sure the dates were in date format
Yep.
because they were a little bit different. So basically, the what I described to you earlier is what I did. I went into Studio and set everything up in Studio, except for that. How do I take that attribute thing and flatten it out?
Yeah.
So then I took and I went from Studio. I could have actually done this in Studio with the custom field thing if I want, custom function thing if I wanted to, but um, this actually turned out to be a little bit easier. I took that script that was built up in Studio and I went into a Jupyter notebook. And right at the end, before I wrote it out to Parquet, I did a little fun thing that is provided to you by AWS. So for people who are familiar with Spark and Pandas, you're familiar with data frames.
Yes.
Data frames are kind of the base structure in which the data is kind of loaded and processed.
Mm-hmm.
A couple of the difficulties with data frames are strongly typed.
Yeah.
They need to be typed early.
I've had some interesting experiences. I know I reached out to you one day when I was doing a data science project for a client and could not figure out why it was not working. But then we figured out that okay, when it got put in the data frame, it actually changed the type.
Yep.
In the process.
So when AWS introduced Glue, they introduced a new structure called a dynamic frame.
Yes.
And while it's not exactly this, I like to think of it as a wrapper around a data frame.
Mm-hmm.
But the reality is you can convert a dynamic frame to a data frame and back if you want to. But what's cool about a dynamic frame is, first of all, there is no pre-interpreted schema. It's schema on reference.
I
right?
wish I would have known this one.
So I have a column. It happens to have only string data in it. When you first load the data in the dynamic frame really doesn't care what that is, and it doesn't make note of it.
Mm-hmm.
When you try to access that column and process it, that's when it says, oh, this looks like a string. But because of that, you can actually have a column that has numbers and strings, and that value of that column, whether it ended up being a string or a number, could be dependent on another column.
Hmm.
So this is a column that actually has multiple types in it, and they're both valid types.
Oh.
So with dynamic frames, you can basically go through and say, oh, okay, so I want to do a transform on this, and I recognize that this is a multi-type column, and I want to actually basically blow that out into two separate columns based on this other column.
Yeah.
Right? So now I can have a string column and an integer column, and if this first column is A, that value goes into the string column. If it's B, it goes into the integer column, and they're now strongly typed as those things.
Wow.
So it has a whole lot of cool things. The other cool thing it has is a function called relationalize. And relationalize takes a field in your dynamic frame and assumes it is a nested structure, and it basically creates top level attributes in a dotted notation.
So it's just doing that exact thing that
it's doing exactly what I needed. So I basically had to add one function call in PySpark to call relationalize on that dynamic frame, and now I had exactly what I needed. Wrote it out to Parquet, query it with Athena, good to go.
Where otherwise you might have had to parse out that entire file into multiple. That could have been a nightmare.
Right. Well, and here's where, kind of to circle back to the Glue crawler. We talked about the Glue crawler and creating a table. But the nice thing about the crawlers is the crawlers can be scheduled to run or triggered to run, on demand if you're by an event if we need to run on a regular basis. And what's cool about that is the crawler can update the schema. So let's take these attributes that we were just talking about, right? And they're coming out of log files. Say we start consuming logs that have 5 new attributes we've never seen before.
Yeah.
Well, because these attributes are being promoted up to a top level as a top level field in that schema, they're not in my original schema that I crawled.
Yep.
Right? But if I run that crawler on a regular basis, every night, twice a day, whatever, it'll recrawl the files and it'll say, oh, I've got 5 new fields here. And it'll actually update the schema in the Glue catalog to have those new files. So as a querier, as a user, whether you're using Athena or Redshift Spectrum or quick site, the next time you go in to run that query, suddenly you'll see I've got 5 new fields that I can query against.
Mm-hmm.
So that's the kind of the benefit is now suddenly it's hands off. That field can change dynamically. We can add all the different attributes you want, and the schema will by itself continue to expand and grow to include those things.
Mm-hmm. Would you ever maybe put some sort of a notification or any sort of warnings when it goes to update a schema at all? Or I guess is there
Yeah,
any implications that it might have?
yeah. So that you can tell it to record the schema changes, but not actually update the schema.
Okay.
Um, you can, if fields stop showing up, you can tell it to delete them, or you can tell it just to make note log it. Right.
Yep.
There are a number of ways that you could create hooks on it to actually send events out to notify people that 5 fields have been added.
Yep.
Right. Some of that requires a little more programming, lets you dive into Lambda and Event Bus and a few things like that. But yeah, there's no reason why you can't make that happen, right? You could create something that looks for a schema update event, triggers a Lambda who puts together a message, sends it out via SES or sends it to the chat bot and it posts it to a Slack channel.
Mhm.
You've got all kinds of different ways you can do that.
Yeah, and that's a good thing of just while we're on the notification, kind of track here. What about sensitive data or any data that might trigger some compliance issues?
Right. So, this is an area where I don't have as much hands on experience, but the features are there. There are capabilities within Glue to do data filtering for compliance reasons or for sensitive data. So, there is some sensitive data detection functionality
Yep.
that's available that you can bring into a Glue job. So, if you think about, if you've ever used like Amazon Macy,
Yeah.
for looking for PII and PHI and stuff like that in S3 files. A lot of the same types of technologies can be run against the dynamic frames in Glue. So if you're going to be building this stuff out, you can actually run a sensitive data check. You can do remediation on that sensitive data, things like that. We'll do another session on lake formation. And what's interesting there is while you can use Glue to remove or remediate sensitive data, there may be reasons why you need to keep it in there.
Yeah.
And data lake formation allows you to control access to data in the data lake all the way down to the column and row level.
Yeah.
So you can say, yes, I have sensitive data. All I'm going to do is mark it as sensitive data, but I'm going to only let certain user types, certain roles access that sensitive data, but it would be unavailable to anybody else.
Yeah. Which similar to the recent Lambda updates as well, and being able to really have more robust control around your access. So how about when you get into any issues and you need to explore where you might have some code failing, or being able to really introspect the different pipelines that you might be creating.
Okay. So a couple of things that you've got is obviously you've got CloudWatch.
Mm-hmm.
So all the Glue jobs will push out to CloudWatch. Um, you've got things like the Apache Spark UI. Um, you can actually pull data out of CloudTrail and analyze it as part of that process as well. There's a lot of different ways. If you're using a third-party toolset like New Relic or Datadog, most of those have the ability to ingest some of this information and provide alerts as well. Um, but you can build and monitor them. The things that you want to watch in that spot are um, obviously, are you having job failures? Are you having issues? Are there errors that are coming out of it? The other thing you want to watch is how fast are they running and how
Mm-hmm.
much scaling are you doing, right? So
Yeah.
you can automatically scale based on the workload, but um, the other side of it is it may be cheaper to let it run longer
Yeah.
than scaling it up, or it may be that you're not really scaling it up and it's taking longer and longer because the data is getting bigger and bigger.
Yeah.
What was being sent to you at 1 gigabyte became 10 gigabytes a day, became 100, became a terabyte a day, became 10 terabytes a day, right? And you need to scale things up. So that's a part of it. The other piece of it is they've got these workflows and blueprints that allow you to basically define a higher level flow of jobs, right? So I need to do this, and process this data. And once that's ready, I can trigger these three other jobs that can run in parallel. And then when those are
Mm,
done, other things.
similar to what a step functions type or
Right, right. Think of it as step functions at the glue job level,
yep,
right?
makes sense.
But the downside of that is if any one of those errors out, that could cause a downstream
Oof.
problem and prevent downstream work from happening, right? So monitoring and alerting on that is important as well.
So there's been a lot of different updates and a lot of advancement in Glue, especially Data Brew come out over the last couple of years here. What are some of your favorite updates that you have come in Glue, and how have you utilized them?
I'm going to mention one and then defer it because I think Glue Data Brew was one of
Yep.
the great updates.
Yeah.
Like I said, we've got another episode. We'll talk a little bit in depth about that, and hopefully there you'll understand why I think it's one of those. Glue Studio is a much richer version of what they had before with Glue Jobs to do visual stuff. It used to be, you know, I'd set up the read and the write, and then I'd just drop into the Jupyter notebook from there.
Yeah.
Now it's a lot easier to do more complex stuff with Glue Studio. One of the ones that you probably don't see as much from a user's perspective that I think was really important, and I'm trying to remember the exact name. I think they refer to them as flex resources or flex jobs.
Yep.
Basically, it's the equivalent of spot instances for DPUs, for data processing units, right? So the idea here is that rather than spinning up a dedicated set of resources to run your job, you'll look at excess capacity and use that instead. Think about there's all these resources being spun up, and in traditional kind of fashion, they don't spin it right down as soon as something's done with it. It goes to a pool because there's lots of other glue jobs. But if that pool, doesn't have a lot of demand on it right now, yeah, eventually they'll start cooling those down. But if you're running flex jobs, yeah, you can leverage something out of the pool, but you might be kicked out and your job may have to restart later if regular demand comes up for them.
Yeah.
Especially on the development side, there's some risk on the production side, but it really brings the cost of running glue jobs and especially building and doing exploratory work with glue down.
Yep. And that's really what I love about AWS is that they do a lot of things that it's probably saving them money and helping their performance, but they bring that back to the customer to be able to benefit from that
Mm-hmm.
and say, hey, might not be for certain types of workloads, but here there's an option to do this. So if you're, like you said, if you're doing development, you can leverage that. And I think that's one of the great things about AWS and just the Amazon mantra in general is getting
I,
those cost savings back.
I completely agree. One of the other, this is not a glue specific thing, but it's an enabling concept. And we've mentioned this in other episodes is AWS has made a push to enabling SQL as a primary language for data
Yeah.
processing, right? And so you think about what we talked about is I can take with a glue job, I can take a CSV file, do some processing on it, and write it out as a Parquet file, right? And that processing could be anything. I could actually take this file and do an aggregation and write a summary data set out, right? I can do that with Athena. I can write a SQL query that generates that summary, and I can use a CTAS, a create table as
Mm-hmm.
statement in Athena to generate that same thing out onto S3, catalog it, and query that way, right? So now I can use SQL rather than PySpark to do it. So bringing that full circle back to Glue, other things that have been, in preview for a while or coming out are things like Glue Elastic Views.
Yes.
So earlier we talked about in the Glue catalog, you can actually create connections to all these different data sources, RDS, on-premise databases, all these different things. Well, a number of those will be available via Glue of Elastic Views for query purposes.
Yeah.
So what Glue Elastic Views do is allow you to basically create queryable views across multiple data sources that are connected in Amazon Glue Catalog. So now, rather than writing a job in Glue Jobs that goes and pulls the data out of SQL Server and then pulls other data out of Aurora and
Yeah.
joins it together and filters it and aggregates it and writes it out, I can actually do that with SQL in Athena.
Yeah, and everything, and you're not having to move it less or more than you have to, and
Right.
especially if there's any compliance issues, that's a big thing. A lot of things that I see these days is nobody wants to have to copy the data, and they want to be able to virtualize it and access it. And I know that you've seen that one for a while,
Oh,
and
yeah.
I'm really excited for Elastic Views. I think that you're going to be able to have your business analysis running, massive ETL jobs almost. It's kind of funny.
Yep. Yep. And what's beneficial there is that there's obviously a cost with all of these things that you
Yeah.
do,
Yes.
but these are designed for a lot of scale.
Yep. And
So
you get the thing about it is though is you get the subject matter experts that would usually have to go maybe reach out to two, three other teams, maybe even more than that, just to get their one data set that they want to be able to utilize. That only they really understand the ETL engineered or ELT engineers that they have. They might not know anything about the data. That might be a whole nother meeting just in itself. So it really does accelerate, the usability and democratizes it. So we thank
excellent.
AWS for that.
Well, yes, we do. And if I were to kind of pick at one area in Glue and AWS ecosystem in general that I think is ripe for improvement, it's in a end user facing catalog.
Hmm.
I think we've got some basic capabilities in QuickSight. We've got some good basic non end user capabilities in Glue Catalog. Um, but you look at some of the kind of next gen data cataloging platforms that are out there. AWS needs something like that to further enable enterprise self service
Yep.
around data processing, data cataloging, or data visualization, things like that.
Yeah. I saw a really cool technology that it was basically like a cool work. It was a canvas almost where you could have different notebooks lined up and you could connect the notebooks. You could see the job and just, if there's one thing I'd like to see more visual capabilities and how you can utilize that. So really kind of to your point there. So
Excellent.
I'm sure that'll be coming soon though.
I'm sure it will. I'm sure it will. Well, we should probably wrap this up for today. I'd like to once again thank everybody for joining us today. We hope you did learn something new today, and we'll have more good information like this coming forward in the future. So we'll let you know when we're going to be live next. I think we've got something coming up in a week. We're going to be launching our first IRL episode, which is in real life, where we interview people who are building with AWS and learn a little bit about their successes and failures and lessons learned and
Mhm.
how you can avoid some of those lessons the hard way, right?
Yeah, learn them ahead of time. And yeah, I'm really excited for that episode. So that's going to be a good one.
All right. Well, thank everybody. Thank you, everybody. And we will see you again next time.